Welcome to this explainer from Forge College. I am so thrilled you're here today because, well, we're putting on a show. Or actually, scratch that. We are setting the stage for one. You see, if deploying a smart contract to the live blockchain is like opening night on Broadway, today we're talking about the rehearsals. We are taking a deep dive right into testnets. We'll figure out exactly what they are, why they are absolutely crucial for deploying smart contracts with confidence, and how you choose the right one so your opening night goes off without a single hitch. Okay, let's dive into this.
Now, if you were with us for a previous lesson, you know we got totally in the weeds looking under the hood of the turbine architecture. We looked at exactly how that engine actually works. But listen, knowing the script inside and out just isn't enough, right? I mean, you wouldn't shove your lead actor onto the stage on opening night without a single rehearsal. No way. And you certainly wouldn't push a smart contract, especially one holding real value, to the live mainnet without safely testing it first. That's exactly where testnets come in. They're where we test drive the engine and rehearse the performance entirely safely, using valueless tokens, so we can experiment wildly without ever risking real funds.
So here is our playbill for today's explainer. First, welcome to the rehearsal, then the cast of characters, the director's trade-off, testnets in the pipeline, and finally, configuring your environment. Let's get right to it.
Part 1. Welcome to the rehearsal, preparing for opening night. So why do we actually need all these different types of testnets before we push our code to the live mainnet? Well, it all comes down to one absolutely crucial concept. And that concept is environment parity. Basically, environment parity means matching the relevant characteristics of production that matter for the specific test you want to run. Think about it kind of like a theater's acoustics. If you practice all your lines in a tiny carpeted room, you are going to be completely shocked when you step out onto a massive, echoey Broadway stage. Parity means making sure your rehearsal stage sounds and feels exactly like the real thing, so there are zero surprises when the curtain finally goes up.
Moving right along to Section 2, the cast of characters. To achieve that perfect parity for the different stages of our development, we actually rely on 4 distinct types of testnets, and each one serves a highly specific testing goal.
First up in our cast, we have local networks. These are single machine or in-process blockchains that run right on your workstation. Now, notice the emphasis here on instant feedback. Think of a local network as your closed-dress rehearsal. You're the director, and you control literally everything. You can reset the state instantly, you can manipulate block times, and perfectly control the lighting and cues. You're prioritizing developer velocity over complete realism here, which makes it absolutely perfect for rapid iteration and unit testing.
Next up, we have private testnets. These are networks you run specifically for your own team. You still control the nodes, sure, but they provide a persistent state. This is essentially your full run-through with a limited, invited audience. You're going to use this when you need multiple users, background services, or really complex scene changes. It beautifully approximates a production rollout, but without exposing your unpolished work-in-progress code to the general public. Then, we introduce just a little bit of beautiful chaos. Public persistent testnets. These are community-maintained networks that act as our preview nights with a real, totally unpredictable audience. You don't control the validators here, and you definitely don't control the network congestion. It models the real-world delays and the client diversity of the actual mainnet perfectly. You use this for your final integration tests and external compatibility checks, where you absolutely need an environment that mirrors the wild unpredictability of production.
And finally, we have forked testnets, sometimes called mainnet snapshots. Honestly, this is an incredible tool. You are essentially taking a recent copy of the live mainnet state and running it locally or ephemerally. Imagine practicing on the exact opening night stage, complete with the real set pieces, but it's totally isolated with ghost actors. You can interact with live protocol contracts and real token balances, but because it's isolated, no real funds are ever at risk. It balances absolute realism with total safety.
Which brings us to part 3, the director's trade-off. Now, you might be sitting there wondering, well, why not just use the most realistic testnet all the time? And that's a fair question. But as a developer, you always have to balance your priorities.
You are constantly juggling these 3 constraints: fidelity, control, and cost. Fidelity is how realistic the environment is. Control is how easily you can reset or manipulate things deterministically. And cost? That's the developer time and the maintenance burden required. So here's the crucial point. You simply cannot have a perfectly realistic, completely controllable, and dirt-cheap environment all at the same time. It's the classic engineering dilemma. Pick 2 and weep about the third. If you want high fidelity like a public testnet, you're going to lose control, and it might cost you serious time debugging flaky network issues. But if you want high control, like a local network, you sacrifice the fidelity of real-world network ingestion. You really just have to choose the right tool for the specific job. Let's look at part 4, testnets in the pipeline. How do we map these distinct mental models and testnet types directly onto a real-world deployment pipeline?
It generally follows these 3 steps. Step 1 is rapid iteration, where you use your local networks for unit tests and instant feedback. Step 2 is integration or staging, using those private or shared devnets so the whole team can test multi-node interactions together. And step 3 is pre-production verification, using forked mainnets or public persistent testnets to ensure everything works flawlessly against live data and real network conditions. By the way, in our Forge College programs, we actually walk you through setting up this exact professional workflow step by step. Because honestly, mastering this pipeline is what separates the amateurs from the elite Web3 developers.
Okay, final section, configuring your environment. We are moving from the abstract theater concepts into the concrete reality of rigging the stage. How do we actually hook all of this up in our code?
This matrix you see right here, this is essentially the blueprint for your deployment toolchain. Notice how the recommended config perfectly matches the goal of the testnet we talked about. For a local network, we set automine to true because we want that instant speed. For a public network, we use a public RPC and a canonical chain ID so we can connect to the real community testnet. And for a forked network, we use a mainnet RPC. But crucially, we pin the block number. That means we literally freeze time at a specific block so our tests are perfectly reproducible. This configuration is pure gold when you're writing your actual setup files.
But hey, a stage doesn't stay rigged forever, right? You have to plan for life cycles. Public testnets get deprecated. Networks upgrade all the time. If you don't plan for this, your automated continuous integration tests will just suddenly break for no apparent reason, and you'll be pulling your hair out. So you absolutely must pin important tests to snapshotable states, pin those block numbers on your forks, and record your RPC endpoints clearly. Proper documentation is exactly what makes your pipeline predictable, reproducible, and completely free of those dreaded flaky tests. So I'm going to leave you with this final thought. Which stage will your smart contract debut on? Now that you know the cast of characters, from the highly controlled local networks to the beautifully chaotic public testnets, you have the foundational knowledge you need to build a robust, professional testing pipeline. Don't leave your opening night to chance. To master these deployment pipelines, dive deeper into the configurations, and explore more incredible Web3-related topics, I highly encourage you to visit forge.college. Grab your tools, rig your stage, and I will see you in the next explainer.